thanks for having me. I'm excited to do this. I was excited to come to SF and then everything happened. So now I'm happy to join you from beautiful Toronto, Ontario, in Canada. So yeah. So I'm going to do something a little bit different. Everyone's been doing slides. I only have a few slides here and I'm going to run through them real quick. Slideshow. And then I'm going to do some kind of live coding. So today we're going to talk about PyTest. We're talking about, you know, how to become a better developer and how to become a better Python developer. So I want to talk about PyTest as a tool and how you can use it for all of your test automation needs. So a little bit about me. So I'm a solution architect with Sauce Labs. So as Daniel mentioned, Sauce Labs is a continuous testing platform. I've worked with some really great customers that you've heard of, like companies like Disney and American Express and some other kind of big deal companies. Really exciting. You can find me on Twitter, Josh in 4 colors. I tweet about test automation and other things. And of course, I love Selenium, love Python. It's great. And lastly, Sauce Labs. So we love Python at Sauce Labs. A lot of our backend services are written in Python. We have some really strong Python developers on staff. Python is a first-class language in the Selenium community. So there are Selenium bindings. There's some really smart people that work on Python and Selenium and test automation in general. So, so we love it. So that's the end of the slides. Let's close this up. So, oh, get rid of this and get rid of this. So what I want to do is I want to do some samples. I want to show how PyTest works. And I want to look at different styles of tests that you can write. So you can think of unit tests. So if you're writing just a small piece of code, a module, a class, something, a service, and you want to test it yourself, you want to verify it works, or you want to practice test-driven development, like what would those kind of tests look like? Excuse me. If you're testing services or APIs, so something within your team or something outside of your team, and also end-to-end or browser-based tests. So I have this full application. I want to use something like Selenium to test that. Excuse me. And so I want to show what those kind of tests look like and how PyTest can be awesome for all of these cases. If you are a Python developer, I want you to take away how to write some good tests or to think about writing automated tests with Python and with PyTest. If you're a test automation specialist like myself, it's kind of what I've been doing for the last 10 years. I want you to kind of think about PyTest as a good tool in your toolbox to use. So let's take a look. So let's start at the bottom or start at the top. Bottom, top, yeah. So let's say I'm writing, and that's the other thing. We're going to talk about the weather. So we're going to keep things nice and easy. What's a topic that Canadians love talking about? The weather. So let's say I have this class. Let's say I'm writing a feature and I have this class. So this class is for temperature conversion. This is a very simple class I just kind of came up with, and it converts Fahrenheit values to Celsius, and it converts Celsius values to Fahrenheit. So very, very simple. You can imagine maybe there's some other more complicated things. Maybe there's like weather forecasting in here. Maybe there's some kind of other temperature conversion that happens. But for simplicity, this is just a very simple class. You might write this as part of a feature. So how would I test this? Well, let's take a look at some tests. So I'm going to use PyTest. I've created this file called test_PyTest. And I'm going to just install PyTest. I did already install it, but it's pretty easy. Just pip install PyTest. And then I've written this test. So I import my class that I want to test in a very conventional way. And I've written 2 functions. Actually, let's get rid of this for a second. So I've written 2 functions, test freezing Fahrenheit and test freezing Celsius. And so these are really, really straightforward, right? So what are some basic checks that I can, write to make sure that my temperature conversion works? Well, I know that, for the freezing temperature is consistent of water. So freezing, so water freezes at 0 degrees Celsius and it freezes at 32 degrees Fahrenheit. So I can use those kind of as data points as to kind of check that I'm not going way off the rails here. So I've written these two functions. They both start with test underscore, and that's it. I haven't imported anything specific to PyTest. I don't need to use object-oriented programming. So I don't have to set up a class. I don't have to import anything. I don't have to understand how PyTest works kind of really deeply. All I need to do is write tests that start with test, T-E-S-T. And in fact, I'll get rid of this. The underscore is just snake casing for convention, but I don't even need to do that. I can even have this. So if I open this up, so PyTest, when you install it, also gives you a test executor. So from command line, I can execute PyTest, tests, calculations, and they run and pass. So I know that I have some confidence that my tests work, or that my class works, and my tests kind of prove that out. If I introduce a bug, let's say, I'm sleepy or something, daylight savings is throwing me off. I should have a minus, I have a plus. If I execute my tests, sorry, I gotta save this. I get a failure, right? So I can kind of see right away, very quickly, if I have a problem, if I've made a mistake, if I've introduced a bug, my test can catch that. And it's very low overhead. It's very easy. I don't have to really know a lot about PyTest. I don't have to know a lot about test frameworks or test automation. The only convention I need to know is write functions, and the functions have to start with T-E-S-T. So if example, I leave this out. It doesn't find it. So that's the only convention I have to know. So that's easy. And test writing should be easy. We want to encourage people to write tests. Writing tests helps you, whether you're using test-driven development or acceptance test-driven development, or whether you just want to verify, does my code do what I think it does? This helps you with that. This helps you with this. That's it. So this is a basic example of unit testing. I'm happy to answer questions about this after, but I mean, this is really straightforward. I've kind of written some, and all I've done is import my temperature converter class, import it, create an instance, get my actual value, compare it against an expected value, and then have an assertion. The other really interesting thing about PyTest as a test framework is that I just use regular plain old asserts. I don't have to know any special syntax. If you've used something like JUnit, or if you've used Node.js, sometimes there's special constructs. There's special assertion libraries or assertion packages you have to import. From Java, there's things like Hamcrest, and or from Node.js, there's something like Chai. So you have to understand those things as well. With PyTest and Python, you can just use plain old asserts, right? Asserts, it's a keyword in Python, works, everything's great. So that kind of takes care of the unit case, right? So I've written this class, it's very simple. I can run tests and they're very, very fast. Right? This took 0.04 seconds, very fast. So I can write a lot of unit tests, everything's good. So now let's talk about testing kind of one level up and talking about service testing or API testing. So let's say I have an API and we're still kind of in this weather realm. So there's this really great service called, get rid of that. And get rid of this maybe. So there's this service called Open Weather, or Open Weather Map. It's a really great service. It's open. There's the free tier account, and it's an API service that you can use to pull down weather information. So temperature, weather conditions in all sorts of points all over the world. And if I open this up, so if I hit this API, I get back, so I make a request, I get this response with this information. So at this longitude and latitude, I can get like information like, you know, what's the description of weather as clouds, right? Scattered clouds. I can get things like temperature, maximum temperature, minimum temperature, what's the humidity, that kind of thing. So this is a service that I might depend on, right? Maybe I'm writing some kind of weather forecasting application, or maybe I'm just doing something weather related and I'd like to pull down this information. Or maybe someone on my team, or even myself, I'm writing an API and I'd like to verify this API works the way that I think it should work. So if you think about like a basic RESTful API, I make a request to an API somewhere, could be local, could be hosted somewhere else. And that API should return a response that is what I expect, right? So I should get a 200 level response if it's a good response. If I make a bad request, maybe I'll get a 400 level response. If something is super janky happening on the server side, I should get a 500 level response, right? Kind of loosely speaking. So how can I test this, right? Let's take a look at what this might look like. So here's a test for this weather service. So here I'm using requests, the beloved HTTP request library from Python. It's wonderful. And I'm doing something really, really straightforward here. So again, I'm gonna just write two simple tests for this open weather API. First test is the service up, right? So, you know, if I make a request, am I gonna get back some kind of response that I expect? Like, does it work? Maybe this is third-party service that I depend on, right? Like going back to that example. So I wanna verify that works. So I put together my URL. I also have an API key associated with my account. So I kind of construct this, and I want to get back information related to Toronto, where I am. I want to know what the weather conditions are in Toronto right now, or, you know, within the next 24 hours. So I assemble my, I assemble my URL. Simple get request, request, and then I get back a response. And for the test services up case, I just want to verify that like I get a 200 back, right? So is this service working? So I also might want to verify that I get back the appropriate information. So in addition to, is the service working? Is it up? I also might want to know, can I get back the current temperature? That might be the only thing I'm interested in, is getting the current temperature. So I'm going to make the same request, get back a response, process that response, you know, into JSON and kind of parse it through. And I want to verify that I get back this value that by inspection I figured out is what the temperature is, like in the response body. And I just want to verify that it's there, that it exists. It's not empty, it's not ill-formatted or something like that. So let's take a look at what this is. Okay, and again, so I execute the tests exactly the same way. So whether it's a unit level test or a service level test or some other kind of test, PyTest executes in the same way. So I can even group those things together and I can execute those things together. It's very nice. And I get this nice output. So this looks great. Now, here I'm copying and pasting this code, and astute viewers or participants or people kind of watching might think, you've been doing a lot of copy and pasting, Josh. Like these lines are exactly the same between this test and this test. If you write more tests, if you write more test functions, you're going to have to copy and paste this more. And it was the same thing in my unit tests, right? I had copied lines from each unit test. So if I add more and more, I'd have to copy and paste that, which would get difficult to manage. You know, is there a way to kind of simplify that? And the answer is yes. So this is where I'm going to introduce the wonderful feature of fixtures. So here is, let's get rid of this. So here is the same, basically the same tests, but using a PyTest fixture. So now I'm going to import PyTest. I'm going to start using PyTest functionality. and I import PyTest to use this PyTest fixture. So fixtures are basically functions that are decorated so that you can pass in, you can basically construct objects or construct entities, I guess, generally speaking, that you can kind of pass into tests, right? So in this case, like I'm constructing, I've called this endpoint, but I could have called it anything. It's just a function, right? It's just a function with this decorator. And what I'm doing is I'm creating this URL. So I'm getting my API key, I'm constructing this URL, I've kind of split out my base URL for all requests, and this is a specific request. I'm interested specifically in Toronto, and I want my units to be metric, and so on and so forth. So I construct this URL, and then I return it. So this function just returns this URL, and now I can pass in this function as a fixture to other tests. So what PyTest will do is PyTest will assemble all of this test execution, and it will logically apply these values to the test functions, if that kind of makes some sense. So I've defined this thing endpoint, and now I can use endpoint within certain tests. And if I execute this, fixture, the test is exactly the same. It works exactly the same as in the case without fixtures, but I get the added feature of being able to kind of carry around this code, so it's not repeated. It's not copied and pasted everywhere. There's also constructs in PyTest, which I'm not going to show here, but for, like, let's say I want to apply this fixture to a bunch of other files, or if I want to organize my tests into multiple directories, there's conventions and sort of ways of doing that in PyTest that are logical. But for now, like, just know that like you can define a fixture in place in a file. So this is nice and clean and easy breezy. And then also like PyTest as a test framework, or I guess a test execution framework. I don't know how to think about it. It's very easy to integrate kind of other PyTest, or sorry, other Python modules into there. So using requests, using OS, there's not a lot of overhead. You don't have to kind of pass things around or other shenanigans. Okay, so we've covered some unit testing. We've covered some API level testing or service level testing. Let's talk about browser testing. So you're not gonna get me out of a test automation talk without talking about browser testing. Not that easily anyway. So I'm going to close all this up. So let me show you my handy dandy application. So let's say I have this application. This is my Celsius to Fahrenheit calculator. Maybe this is the first draft. This is my MVP of some impressive weather-based application I'm going to test. And it's really easy. It's got two inputs, and it does Celsius to Fahrenheit conversion. So I can do, 7 degrees Celsius is 44.6 degrees Fahrenheit, or I can enter in this here. It tells me that. Okay. So how would I test this? I want to test this in place, and I want to use a browser to test this. So you can do that using Selenium, which is a great tool for this. So what's this test looking like? Well, let's take a look here. So similar as before, I'm using PyTest to write some tests, and I want to verify two different things. I want to verify that my message appears. So when I input some value to Celsius, I get that temperature message appearing with Celsius and Fahrenheit. And then it also tells me that the message is correct. So thanks to my unit tests, I know my calculations are good. I know that my Fahrenheit to Celsius conversion is good, right, if all those tests pass. So I don't have to verify that at this level. What I do need to verify is the message correct? So when I actually input this value of 0 for Celsius, do I get this specific text back for my message, right? So these are two kind of end-to-end style tests or these are two tests that you can use to verify that your application works sort of at a functional level, at a browser level, right? So web application, does it work as expected in browser, what an end user might see. So let's run these tests. All right, so this is going to fire up a Firefox browser. Going to visit this page, quickly enter in stuff. Computers tend to be a lot more efficient than human beings in this kind of thing. Okay, those two tests run and execute, and they pass. So yeah, I'm going to kind of browse over, or I'm going to gloss over these details, but both the tests pass. So my message appeared, and the message was correct. So this doesn't look too bad, right? Now you might be thinking to yourself, this is pretty good. This is pretty good. Like you have this fixture, it starts a WebDriver instance using Firefox. Yield is a really cool feature in PyTest. So in Python 3 with later versions of PyTest, yield is you can kind of think of it in fixtures as a return statement that doesn't actually stop the execution of the test. So whereas a return would kind of end here and not execute this last line, yield returns this instance of Firefox WebDriver, but you continue down. So this is kind of like a setup. This is kind of like a teardown. So start the test by opening the browser, finish the test by closing the browser. So this is looking pretty good, except for when I want to change from, say, Firefox to Safari, right? Do I really want to go in and do I really want to change this value every time, right? Or what if you are not using a local version of a browser, but what if you're using a remote version of a browser? What if you're using the industry-leading continuous delivery platform or continuous integration and continuous testing platform known as Sauce Labs, or one of the other ones? That would get complicated too. You have to go in and do all sorts of coding and stuff, and like it just seems kind of awkward. So this is where I'd like to kind of introduce that PyTest has some really great integrations, or sorry, not integrations. It has some really great plugins. So it has a great plugin ecosystem. Other smart developers have encountered problems to this when it comes to test execution. And so they've shared that knowledge and kind of put together plugins for accomplishing kind of particular tasks. So the one plugin that I want to talk about is PyTest Selenium, this very cleverly named plugin. So what this plugin does, a few things. And I'm going to install it same conventional way, PyTest Selenium. Okay, installs, it's already there, but same idea, pip install. So what this does is it provides a few fixtures off the shelf, so to speak. So this is now sort of in my Python path. This is in my virtual environment. So something like this. So instead of writing out my own fixture called Selenium that contain clever things, there are other people who have done even more clever things. The original author of this is, I think, Dave Davidson, a gentleman located in the UK. Yeah, smart guy. I think there's some other authors too, but they put in some really great knowledge into how to construct this. So using this, so now that I've installed this plugin from pip, now I automatically have this Selenium fixture. So I can just start using it right away. So this creates a browser instance similar to what I had before, but you know, again, with some more functionality and more features. So these tests are basically the same, except I'm using this Selenium fixture instead of my custom browser fixture. The other thing that PyTest Selenium gives me is it gives me some additional PyTest command line options. So now I can select a driver at runtime from the command line. So here I'm specifying Firefox. I run. Same as before, Firefox instance opens up, goes to my application, check something out. Second test runs, executes. Okay, test pass. So that's really cool because now it's a pretty low overhead way to say like, well, you know, someone said we should really test because there was a bug on Safari, so I'm going to test on Safari. So now I run and execute, and then at runtime, I now open up Safari instance, and Safari can then, you know, I run my test through Safari. And the test passed. Very good. In 6.66 seconds, not ominous at all. But you can even do some more fun things. So there's other plugins too for PyTest, such as PyTest variables. So just to kind of show this. So another driver you can select is Sauce Labs. I know, excuse all the Sauce Labs plug. Oh, actually. So I can do pip install PyTest variables. Variables allows you to specify options at the command line in JSON, in a JSON file. So if you have relatively complicated options, instead of passing them all in at the same time, you can pass them in as files. So for example, if I have PyTest Sauce Labs, Firefox JSON test app with plugin. Oh dear. Oh, I don't know why this happens. Anyway, this should work. It's a virtual environment situation. Not really sure if I can fix it right now, but trust me, it'll work. I wonder if I go deactivate. Yeah. Sorry, so I don't want to let Tristan down. You know, he's, no. Install PyTest. Okay, anyway, that's another feature. This was literally working just before the meetup. Oh, that's so rough. Okay. I knew it was too good to be true. But it's another feature in this plugin, so it has some very clever kind of things in there as well.